On July 1st, 2025, a telescope in the mountains of Chile detected something moving across the sky that did not belong here. Not in the way that unusual asteroids do not belong here, or in the way that rare comets from the outer solar system occasionally wander into the inner planets on long, looping orbits that take thousands of years to complete. This was different. The speed was wrong, the trajectory was wrong. The mathematics of where this object had come from, when worked backward through months of careful orbital calculation, pointed unambiguously to a conclusion that only two objects in the entire history of human astronomy had ever forced scientists to reach before. This object did not come from our solar system. It came from somewhere else entirely, from another star, from a planetary system orbiting a sun that our telescopes cannot even individually resolve at the distances involved, carrying with it the frozen chemistry of a world we will never visit, traveling through the void between stars for a journey that the best available estimates suggest began more than 10 billion years ago. It entered our solar system as a stranger, and when the greatest array of space telescopes ever simultaneously pointed at a single object began taking it apart chemically and physically, what they found inside it was something that has no equivalent in anything that has ever formed around our sun, something that does not fit, something that came from out there and brought with it evidence of conditions, of chemistry, of a history so alien to everything we know that the scientists analyzing the data have been using a word that does not appear often in the careful, measured language of peer-reviewed astronomy. Terrifying is not their word, but what they found is exactly that. The object is called 3I Atlas. The designation encodes its significance in a compressed scientific shorthand. The 3 stands for third. The I stands for interstellar. It is the third confirmed object ever found passing through our solar system from outside it. The first, discovered in 2017 and named 1I Oumuamua, was a flat, elongated reddish object that accelerated away from the sun in a way that no known natural force could fully explain, tumbling through space with a shape and behavior that generated more scientific papers per unit of observation time than almost any object in the history of astronomy, and that left the field without a definitive explanation for what it was. The second, 2I Borisov, discovered in 2019, was recognizably a comet, carrying its coma and tail like a familiar flag, easier to characterize than its predecessor, but still foreign in its chemistry, still carrying the signature of another star system's raw materials and its dust and gas. Both of them came and went before the scientific infrastructure to study them properly was fully operational. Both of them left questions that could not be answered with the instruments available at the time. 3I Atlas arrived when the instruments were ready, and the difference between what humanity could do with Oumuamua in 2017 and what it could do with 3I Atlas in 2025 is the difference between glimpsing something through a keyhole and throwing the door open. 14 NASA spacecraft simultaneously observed 3I Atlas. Hubble photographed it. James Webb analyzed its chemistry with the most sensitive infrared spectrograph ever built. Sphere-X mapped its dust distribution. TESS tracked its brightness variations. SWIFT measured its ultraviolet output. The Perseverance Mars rover photographed it from the surface of another planet. Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, Parker Solar Probe, PUNCH, and the ESA's NASA Solar and Heliospheric Observatory all contributed observations from their different vantage points scattered across the inner solar system. ESA's JUICE spacecraft, the Jupiter Icy Moons Explorer, was positioned in a location that gave it a view of 3I Atlas unavailable from Earth and turned 5 of its science instruments toward the interstellar visitor. And on the ground, 31 observatories on multiple continents tracked its trajectory, measured its light curve, and characterized its coma chemistry with every available technique. The entire scientific infrastructure of modern planetary astronomy mobilized around this one object in a coordinated observation campaign that had never been attempted at this scale for any single target before. What that mobilization found begins with the basics, which are themselves remarkable. 3I Star Atlas was discovered on July 1st, 2025, when it was approximately 410 million miles from the Sun, just inside the orbit of Jupiter. Pre-discovery observations, found in the archives of the Vera C. Rubin Observatory's commissioning data, extended the known timeline back to June 14th, 2025, giving researchers an additional 2 weeks of trajectory data to refine its orbital solution. When the orbital solution was computed, it confirmed immediately what the speed and trajectory had suggested. The object was on a hyperbolic path, moving far too fast to have originated anywhere in our solar system, on a trajectory that, when traced backward in time, led not to any region of our solar system but to interstellar space, arriving from the general direction of the Milky Way's galactic disk. It seems to come from the direction of the Milky Way's disk, and was therefore likely created more than 10 billion years ago, making it potentially the most ancient visitor ever detected, possibly older than our solar system itself. The speed deserves its own moment of attention. When 3I Atlas was discovered, it was traveling at approximately 137,000 miles per hour. Pulled by the sun's gravity as it fell inward toward perihelion, it accelerated to approximately 153,000 miles per hour at its closest approach to the sun on October 29th and 30th, 2025. 153,000 miles per hour. The fastest human-built object ever launched, the Parker Solar Probe, reaches speeds of approximately 430,000 miles per hour at its closest solar approach, but only because it has been specifically designed to use repeated gravitational assists from Venus to build up that extraordinary velocity. 3I Atlas achieved 153,000 miles per hour under its own interstellar momentum, arriving with its velocity imparted by whatever gravitational and dynamical processes ejected it from its birth system billions of years ago, and sent it on a journey across the galaxy that ended temporarily in our neighborhood. The size of the nucleus remained uncertain throughout the observation campaign, which itself tells you something important about the object's nature. Hubble observations from August 20th, 2025, placed the upper limit on the nucleus diameter at 3.5 miles and the lower limit at approximately 1,400 feet. That is an enormous range of uncertainty for an object under such intensive observation, and the reason for it is the coma. 3I Atlas developed a robust, actively outgassing coma as it approached the sun, a bright cloud of gas and dust emitted by the sublimating ices of the nucleus that surrounded the solid body with a diffuse haze that made direct imaging of the nucleus itself extraordinarily difficult. Hubble revealed a teardrop-shaped cocoon of dust coming off of the comet's solid, icy nucleus, a structure shaped by the solar radiation pressure and the outgassing dynamics of a body whose interior was releasing material into space at rates that initially surprised the researchers measuring it. The water production rate is the first number that stopped people in their tracks. On November 2nd, 2025, just 4 days after perihelion, ESA's JUICE spacecraft detected that 3I Atlas was spewing out 2,000 kilograms of water vapor every second. 2,000 kilograms per second, equivalent to 70 Olympic swimming pools of water vapor released into space every single day. This is an extraordinary outgassing rate even by the standards of active solar system comets at perihelion, and it confirmed that 3I Atlas was an ice-rich body with a highly volatile interior, responding vigorously to solar heating. An interstellar comet was raining water across our inner solar system, water that had been frozen since before our sun existed, released now for the first and only time in the object's multi-billion-year history by the heat of a star it had never encountered before and would never encounter again. But the water was not the finding that generated the most sustained and careful scientific discussion. The water established that 3I Atlas was an icy body from another star system. The finding that established it was an icy body from an extremely different kind of environment than anything in our solar system came from the James Webb Space Telescope. On June 4th, 2026, a study published in Nature revealed unprecedented details about the comet's chemical makeup. Led by Martin Cordner at NASA Goddard, researchers used Webb's NIR-SPEC instrument to analyze the object and discovered a methane-to-water ratio roughly 11 times higher than any previously measured solar system object, 11 times higher than any comet, any asteroid, any icy body, any object from any region of our solar system that has ever been chemically characterized. Not slightly elevated, not anomalously high by a modest margin, 11 times higher than the maximum value ever measured in anything that formed around our own sun. Methane is a volatile molecule. It is one of the most volatile ices that can be incorporated into a comet during its formation. For a comet to retain significant methane after billions of years of existence, it must have formed in an extremely cold environment and spent most of its subsequent history at temperatures cold enough to prevent methane from sublimating away. The methane-to-water ratio of 11 times any solar system value tells you something specific about where and how this object formed. It formed somewhere colder, somewhere dramatically colder, than the coldest regions of our solar system where comets originate. A planetary system with a different thermal architecture, different distance scales, different stellar luminosity, or different chemical abundances than our own produced this object under conditions that left it saturated with methane that our own solar system's comets simply cannot retain. The deuterium to hydrogen ratio extended the story further. The deuterium to hydrogen ratio was measured at 0.98%, which NASA and ESA note is about 30 times more than found in Earth's oceans. This ratio is a fingerprint. Different environments produce water with different deuterium to hydrogen ratios because the isotopic fractionation process that concentrates deuterium relative to hydrogen is temperature dependent. Cold environments, where chemical reactions and ice formation occur at very low temperatures, produce water that is enriched in deuterium relative to hydrogen compared to water that formed in warmer environments. The deuterium to hydrogen ratio in 3I Atlas's water is 30 times higher than an Earth's oceans. 30 times. This is not a slight isotopic variation. It is a profound chemical signature pointing toward formation in an environment so cold and a history of preservation so complete that the water molecules in this comet's ice have maintained a deuterium enrichment that has no analog anywhere in our solar system. These two chemical signatures together, the methane abundance and the deuterium enrichment, are telling the same story. This object formed somewhere colder and more remote than anything in our solar system. It has been preserved in cold interstellar space for longer than our solar system has existed. And the chemistry it carries is the chemistry of that alien environment, the preserved record of conditions around another star that we cannot visit or directly observe, delivered to our doorstep by 10 billion years of interstellar travel and released into our instruments by the heat of our own sun acting on it for the first and only time. ESA's JUICE spacecraft revealed additional details through its 5 instruments. The comet was emitting water vapor in enormous quantities, as noted. But what JUICE's MAGIS spectrometer revealed about the structure and dynamics of the coma added texture to the picture. The observations showed an active comet behaving in ways that were simultaneously familiar, in the sense that it was doing what comets do when they approach a star, and unfamiliar, in the sense that the quantities and chemical signatures of what it was releasing were unlike those of any solar system comet JUICE's instruments had been calibrated against. Data confirming that the comet was first X-ray emitting interstellar object ever observed came from XMM Newton and X-RISM observations in late November and early December, revealing a diffuse X-ray glow around the nucleus that reflected the interaction between solar wind particles and the neutral gas of the coma in a body rich enough in volatiles to maintain a substantial gas envelope at significant distances from the sun. The SETI investigation ran alongside the scientific characterization and produced its own important result. Given the small number of confirmed interstellar objects, only 3 to date, and the theoretical plausibility of interstellar probes as a possible techno-signature of extraterrestrial intelligence, the Breakthrough Listen initiative undertook a thorough radio search of 3-Eye Atlas using multiple facilities worldwide. The Allen Telescope Array, the Green Bank Telescope, the Meerkat Array, and the Parkes Radio Telescope all searched for artificial radio emission from the object across a range of frequencies from 700 millimegahertz to 12 gigahertz. At the closest approach on December 18, 2025, the Green Bank Telescope, the largest steerable single-dish radio telescope in the world, was sensitive enough to detect a transmitter with an effective power output equivalent to a mobile phone handset. No artificial radio emission was detected. A separate study by Sophia Sheik and colleagues sifted through nearly 74 million radio signals and identified 211 candidates that survived initial filtering, all of which were conclusively identified as human and satellite radio interference. No technosignature stronger than 10 to 110 watts was found, localized to 3-Eye Atlas at any point during the observation campaign. 3-Eye Atlas is, by every available measure, a natural object. Its outgassing behavior, its dust-to-gas ratio, its morphology, its brightness variations consistent with a rotating irregular nucleus, its trajectory precisely predictable by Newtonian gravitational mechanics, all of it fits the profile of a natural comet from another stellar system. What makes it terrifying is not what it is what it contains. It is the evidence it carries of the conditions that made it, preserved across 10 billion years of interstellar cold, released now by our sun into instruments that can read it. It is the proof, written in methane and deuterium-enriched water, that the universe contains planetary systems with chemistries so foreign to our own that objects born in them carry fingerprints we have no local comparison for. It is the demonstration that the stuff between the stars is not empty. It is full of travelers like this one, old beyond comprehension, carrying frozen records of worlds we will never see, passing through our neighborhood on journeys that began before our sun ignited and will end when they finally dissipate in the cold dark of interstellar space after their brief heated encounter with our star is over. 3-Eye Atlas passed perihelion on October 29th and 30th, 2025. It passed Mars on October 3rd, Venus on November 3rd, and made its closest approach to Earth on December 19th, 2025, at a distance of 1.8 astronomical units, 167 million miles, posing zero threat to our planet. It passed Jupiter on March the 16th, 2026, and is now beyond Jupiter in the constellation Gemini, fading rapidly, on an escape trajectory that will take it out of the solar system forever. It will not return. No gravitational influence of our sun will recapture it. It came from somewhere else, passed through, and is leaving, taking with it the chemistry it did not release and the secrets it did not reveal. What it did release, what Webb and JUICE and Hubble and 14 spacecraft and 31 observatories managed to measure in the months it spent crossing our inner solar system, is already being incorporated into models of how planetary systems form, how volatile rich bodies are preserved across galactic timescales, and what the distribution of chemistry across the galaxy actually looks like when you finally have a sample from somewhere other than here. Only 5% of the city has been excavated. Only 3 interstellar objects have ever been detected. The universe is enormous, and the small fraction of it that our instruments have sampled represents a vanishingly small window onto the full diversity of chemistry, structure, and history that 10 billion years of stellar and planetary evolution have produced. 3I Atlas. Opened that window for a few months. What it showed through the gap was enough to confirm that the universe out there is stranger, richer, and more chemically diverse than everything within our solar system had prepared us to imagine. The methane numbers are still being analyzed. The deuterium ratios are still being modeled. The data from JUICE's instruments is still being processed. Papers will continue to appear for years, each one pulling another thread from the chemical fingerprint of an object that spent 10 billion years in the dark between the stars before spending a few months in the light of ours. Something arrived from another star system. What scientists found inside it was the preserved chemistry of a world that does not orbit our sun, frozen since before our sun existed, speaking in the language of molecules, that have no equal in anything we have ever touched before. It left. But the data stayed, and the data says the universe is not what we thought it was before this visitor passed through and showed us, briefly and incompletely and terrifyingly, what it looks like out there.